What's up, everybody, and welcome back to Algebra and Trigonometry, Chapter 2, Section 2, Linear Equations in One Variable. Let's do it. So question 1, what does it mean when we say two lines are parallel? It means that they have the exact same slope. So if I were to draw two lines that were parallel, they would look like this. And also, a add-on to that definition is the fact that if we extend these lines on out forever and ever, they will never intersect. How do we recognize when an equation, for example, y equals 4x plus 3, will be a straight line linear when graphed? So I know that this is going to be linear because there's no exponent value on the x or the y. So it's when they're both to the first power and it looks like this, and pretty much we know, hey, that's going to be linear. When solving the following equation, explain why we must exclude 5 and -1 as possible solutions from the solution set. So the reason why both of these must be excluded is because they are two values that will send the denominators to 0, which means we're effectively dividing by 0. And we can't divide by 0. That's a no-no in math. So anything that's going to make us divide by 0 must be excluded from the solution set. So for this question, all we're doing is we're solving for x, so we're going to use standard variable isolation. So first, I'm going to get rid of that 3 by adding 3 to both sides. So I'm doing the opposite of that subtraction. There's cancel out. Then I have 4x equals 5 plus 3, which is 8. Then I'm going to divide both sides by 4, boom, boom, and x equals 2. Here we're going to start off by distributing that -5. So we're going to get 12 minus 5x minus 15. Again, that negative sticks to the 5 and it gets transferred with that multiplication equals 2x minus 5. Now I've got like terms that I can combine, a 12 and a -15. Those combine to become -3 or -3. And then now I'm going to move the 3 over. So it's a -3, so I'm going to do the opposite. I'm going to add 3 to both sides. These will cancel out. Now I got -5x equals 2x, and then -5 plus +3 is a -2. Then I'm going to subtract 2x. You see I'm consolidating the variables, consolidating the constants, so I'm going to subtract 2x from both sides, boom. And -5x combined with a -2x is a -7x equals, again, a -2 there because the minus sticks to it. Last but not least, we're going to divide by -7. The negatives cancel out and we get a final answer of x equals 2/7. Boom, done. Now, there's a number of ways that we can approach this problem here, but what I want to do is I want to get rid of the fractions because it's going to make everything a lot easier. So how I'm going to do that is I'm going to multiply everything by 12, both sides. And the cool thing is on the right-hand side, these 12s will just cancel out. And I'll have 2x plus 3. Over here, what's going to happen is when we multiply against this guy, it's going to be 12 over 3, which is simply 4x. And here, it's going to be a 12 over 4. That's going to reduce to a 3. And then we're going to multiply by that top numerator. 3 times 3 is 9. The other way to think about that is 3/4 of 12 is 9. Now we're going to combine like terms. I'm going to consolidate. So I'm going to add 9 to both sides so we can combine those constants. And now I have 4x equals 2x plus 12. Then I'm going to subtract 2x from both sides like so. And I get 4x minus 2x is 2x equals 12. Last but not least, we're going to divide both sides by 2 like this. And 12 divided by 2 is 6. Boom, done. First, I'm going to distribute the 3 like so. Then I get 6x minus 3 plus x equals 5x plus 3. Then I'm going to combine like terms on the left side. 6x and 1x makes a 7x minus 3 equals 5x plus 3. Then I'm going to get the constants together. So I'm going to add 3 to both sides like so. And we get 7x equals 5x plus 6. Then I'm going to subtract 5x from both sides like so. 7x minus 5x is 2x equals 6. Last but not least, divide by 2, and we get x equals 3. Boom, done. Once again, I don't want to deal with fractions in this one, so I'm going to multiply by the least common multiple of 4 and 3, which is 12. So we're going to multiply everything by 12. And when you multiply 12 times something over 4, the 12 and the 4 reduce down to 3 because it's basically 12 divided by 4. So instead, it's going to be 3 times x plus 2 minus, and here the 12 and the 3, we're going to divide those, and that's going to become a 4 times that x minus 1 equals 12 times 2 is 24. Now I'm going to distribute these constants like so. So it becomes 3x plus 3 times 2 is 6 minus 4x. And that minus sticks to the 4 as it distributes. So negative 4 times negative 1 is positive 4 equals 24. Now we're going to combine like terms. 6 and 4 make 10. And 3x minus 4x is negative x equals 24. Then I'm going to subtract 10 from both sides. And that gives me negative x equals 14. Then I'm going to divide both sides by negative 1, which is going to give me x equals negative 14. Boom, done. For this equation, we're going to start by stating our excluded values. That's going to be any value that's going to send the denominator to 0, and that's going to be negative 4, right? Because negative 4 plus 4 is 0. Dividing by 0 is a no-no, so x cannot equal negative 4. Now let's go ahead and solve this equation. So what I'm going to do is I'm going to multiply everything by x plus 4. That's going to, again, get rid of the fractions and make this a lot easier. So we're going to multiply that 2 times x plus 4. As I multiply this times x plus 4, you'll notice it will just cancel out with the denominator. So it's just going to be minus 3 equals, again, this times x plus 4, it's going to cancel out. So it's just going to be x plus 2. And now this is a lot easier to solve. Now I'm going to distribute the 2, and we get 2x plus 8 minus 3 equals x plus 2. Then I'm going to combine 8 and negative 3. That's going to give us a 5 like this. Then I'm going to subtract 5 from both sides, and that's going to get rid of that. We got 2x equals x minus 3, right? 2 minus 5 is negative 3. Last but not least, I'm going to subtract x from both sides. 2x minus 1x, it's not just an x, right? It's a 1x, is simply x, which equals negative 3. Boom, done. Here we're going to start with our excluded value, which is what sends the denominator to 0, making us divide by 0, and that would be 1. So x cannot equal 1. Now, once again, I'm going to multiply everything times x minus 1 to get rid of these fractions. So when I multiply the first term by x minus 1, it's going to cancel out with the denominator, leaving 3x. The 2 is going to multiply by x minus 1 like so. And then this is going to be multiplied by x minus 1 as well, and that's going to cancel out with the denominator, leaving just a 3 over here. Now I'm going to distribute that 2, and I've got 3x plus 2x minus 2 equals 3. These are going to combine to give 5x minus 2 equals 3. Then I'm going to add 2 to both sides to move that over, and that's going to be 5x equals 3 plus 2, which is 5. Last but not least, I'm going to divide both sides by 5, and I get x equals 1. But since this is an excluded solution, we already said x cannot equal 1. So if the solution here is 1, it means that there's no solution. Once again, here I want to get rid of the fraction, so I'm going to multiply by the least common multiple of x, 5, and 2x, and that would actually be 10x. So I'm going to multiply everything by 10x. So if I multiply that first value by 10x, the x's will cancel out, and I'm left with just 10. 10x times 1/5, or 1/5 of 10x, is simply 2x. And then here, when we have the 10x over the 2x, that would cancel out to just a 5. 5 times that numerator of 3 is 15. Now we can solve, and we're going to subtract 15 from both sides, and we get negative 5 equals 2x. Last but not least, we're going to divide by 2, and there's our answer. X equals negative 5 halves. And we also need to state the excluded values, and there is one excluded value here, which is x cannot equal 0, and that's because 0 here and here would give us a 0 in the denominator. So there you go. All right, so we're going to start off with point slope formula, which is y minus y1, which in this case is just a simple y value of a coordinate, which is going to be 2, equals m, which is the slope, times x minus x1. That's the x value of the same coordinate, so x minus 1. Now they want us to convert this to slope-intercept form. So all I'm going to do is distribute the slope. That's my first step. So y minus 2 equals negative 4/5 x plus 4/5, because negative 4/5 times negative 1 is positive 4/5. Last but not least, I'm going to add 2 to both sides to get the y isolated. Now, 2 is the same as 10 over 5. I'm turning it into a fraction, an improper fraction with the same denominator as this fraction, so I can combine the two. So now we have y equals negative 4/5 x plus 10/5 plus 4/5 is 14/5. Just add the numerator, and there you go. Boom, done. So again, starting with point slope, it's y minus y1, which is -1, but minus the negative is plus. So we have y plus 1 equals the slope, which at this point we don't know, but I'm going to go ahead and put in x minus x1, which is 4. Now, how do we calculate slope? Well, since they don't give it to us, but they do give us a y-intercept, we've got a second coordinate because remember, at the y-intercept, x is 0. So we can say we got another coordinate at 0, 2. Now, using 2 points, we can calculate the slope because I can subtract the y values, -1 minus 2, over the difference of the x values, 4 minus 0. You see, I'm just subtracting down. -1 minus 2, 4 minus 0. And that gives me -3 on top over 4. And there's my slope, -3/4. Now to convert to slope-intercept form, I'm going to distribute that -3/4. I got y plus 1 equals -3/4 x plus -3/4 times -4 is +3, right? The negatives cancel out. Last but not least, I'll subtract 1 from both sides, and I get y equals -3/4 x plus 2. 3 minus 1 is 2. There's your answer. Done. So here we're given 2 points. The first thing I'm going to do this time is I'm going to calculate the slope. So again, it's going to be y1 minus y2. Okay, so I'm arbitrarily choosing this as my y1. It doesn't matter, but we just have to choose 1 point to be in the front, 1 point to be in the back. So we'll just do it this way. It'll keep all the values positive. So we can do 5 minus 3 over, and these are the x values, 5 minus 1. This gives me 2 on top and 4 on the bottom, which is a final slope of 1/2. Now we can use point slope, and I can use either points here. I'll use 5 just for fun. So using point slope, it's y minus 5, which is the y1 value, equals the slope of 1/2 times x minus x1, which happens to also be 5. Now I'm going to distribute the 1/2. Y minus 5 equals 1/2 x minus 5 over 2. Last but not least, let's add 5 to both sides like this. And again, 5 getting common denominators, we're going to make that 10 over 2. So 10 over 2 plus -5 over 2. So we have y equals 1/2 x plus, we just add the numerators, 10 and -5 is +5. And you notice in these linear equations, we always leave these as improper fractions. Don't try and convert it to a mixed number. That's the winner. Done. So here it says we've got a line that is perpendicular to this line. First, I need to know what the slope is of this line. So I'm going to put it in slope-intercept form by dividing everything by 3. So that gives me 1/3 x minus 4/3. I don't really care about the y-intercept, but that's what this would now look like in slope-intercept form. So the important thing to note here is to get the slope of a perpendicular line, we take the opposite reciprocal of the slope. So the reciprocal of that is 3, opposite is negative. So the slope of our line is -3, and then we got passing through this point. So now we're going to go through point slope. So we got y minus 1 equals -3, that's the slope, times x minus x1, which is -2, but minus a negative becomes plus. Now to get into slope-intercept form, we're going to distribute the -3. We got y minus 1 equals -3x minus 6. And then I'm going to add 1 to both sides like so, and I have y equals -3x minus 5 for the win. Done. Now, normally when we're given 2 points and we're meant to find the equation of the line, we would first calculate the slope, then use point slope, and then maybe convert it to slope-intercept form. But this one's pretty interesting because you can see the x values change, but the y values are the same. So what that would look like is basically 1/7 would be here, and then 3/7 would be out here directly to the right. And this means it's just a horizontal line. And horizontal lines are simply y equals a constant. And in this case, since it's always 7, in both these coordinates and beyond that, it would just be y equals 7, boom, done. When we have a slope of 0, it means we're talking about a horizontal line, which is simply y equals a constant. And since we're given a coordinate, we know what that constant is going to be. It's whatever the y value is of that one coordinate. and that is -4. So y equals -4. Boom, done. Okay, so the first thing I'm going to do is I'm going to calculate the slope. I'm going to take the difference of the y's, and so I'm going to say y1 minus y2 over the difference of the x's in the same order, -1 minus 4. So this is a double negative that turns into a plus, so that's 8 on top, and -1 minus 4 is -5 on the bottom. So there's my slope. Now I'm going to use point slope. So I'm going to say, and I'm going to choose, let's say the first one, why not? So y minus y1, which is 3, equals my slope of -8/5 times x minus x1, that's -1, but that's going to be a double negative, turns into a plus. Now, they didn't say necessarily which format to put this in, but in the answers, they have it in standard form, so I'm going to show you how to turn it into standard form. So basically, first thing is I don't want any fractions here. So I'm going to multiply everything by 5. So that's going to be 5y minus 15 equals -8/5 times 5 is just -8 times x plus 1. Now I'm going to distribute like so, and I have 5y minus 15 equals -8x minus 8. Then I'm going to add 15 to both sides because in standard form, we want the constant on the right-hand side and the variables on the left-hand side. So that's going to give me 5y equals -8x, and the -8 plus 15 is 7. Last but not least, I'm going to add 8x to both sides. So that's going to cancel out there, and now I've got 8x plus 5y equals 7. Everything is as simplified as possible. We've got no fractions, and the term in front of the x is positive, so this is our perfect standard form. Boom, done. So for this question, we're asked to graph these two lines and then state their relationship. So I'm going to put them both into slope-intercept form and then graph them. So check this out. For the top one, I'm going to subtract 3x from both sides first, so that's a -3x plus 5. I'm going to divide by -2, and I get y equals -3 over -2 becomes positive 3/2 x minus 5 over 2. And then for the bottom one, I'm going to add 9x to both sides. So I got 6y equals 9x plus 6. Then I'm going to divide both sides by 6, and we get y equals 9 over 6. That reduces to 3 over 2x plus 6 over 6 is 1. Now, I can already tell that these have different y-intercepts and the same slope, aka they're going to be parallel. But now I'm going to show you in the graph just why they're parallel. So I'm going to start by this one by graphing that y-intercept. That's right there. And then it's a slope of 3 over 2. So I'm going up 3 over 2, up 3 over 2. So there's my line for the first one. Now let's go to the other one. So it's 3/2 x minus 5/2. So my y-intercept is -5 over 2, or -2.5, which is right here. And then again, we're going to go up 3 over 2, up 3 over 2. And there's my line for that one. And now we can see on the graph that they are indeed parallel. 39 is actually pretty straightforward because when you have something like this, x equals 4, it's just a vertical line. And here's how to remember that. So it's saying that x is 4 regardless of what y is. So for example, if y is 0, x is 4. If y is 1, x is 4. X is 4, no matter what. And as you start plotting those points out, you see, oh yeah, that's a vertical line. Likewise, for y equals -3, we say no matter what x is, y is -3. -3 for that x, for that x, for that x. And guess what? That's a horizontal line. So those are the two lines, and they form an exact right angle, which means they are perpendicular. To find the slope here, all we got to do is use our slope formula, which requires the following. We do y1 minus y2, 2 minus -7, over x1 minus x2, -3 minus 4. Again, a double negative becomes a plus. So then we have 9 over -3 minus 4 is -7. There's the slope, done. Once again, to get the slope, we take the difference of the y's over the difference of the x's. So y1, -2 minus 4 is over -1 minus 3. Remember, it doesn't matter so much which order we go in. I could have gone in the opposite order and we would get the same answer. You just got to choose an order and stay consistent with both x and y values. This gives me a -6 over -1 minus 3 is -4. That reduces to positive 3 over 2 as the negatives cancel out. Done. All right, for the top line, we've got y1 minus y2, right? 3 minus 1 over -1 x1 minus x2, -1 minus 5. So that gives us 2 on top. -1 minus 5 is -6, which reduces to -1/3. For the bottom line, we've got 3 minus 9. Again, y1 minus y2 over negative 2 minus 0, x1 minus x2. That becomes negative 6 over negative 2, which reduces to positive 3. Now, since these two slopes are opposite reciprocals, right? If I take the opposite of negative 1/3, that's positive 1/3, and then the reciprocal of that is 3, these two lines are perpendicular. So here they've given instructions on how to graph this on a Texas Instruments calculator, but I'm going to show you on Desmos. So I'll still go ahead and put it into slope-intercept form, even though we don't need to do that in Desmos. So I'm going to subtract 0.537x from both sides. Then I get negative 2.19y equals negative 0.537x plus 100. Last but not least, I'm going to divide both sides by negative 2.19. And that means we're dividing everything by negative 2.19. And what I'm going to do now is I'm not going to try and simplify this at all because I can enter it just like this. And you can do this on the TI as well. It's just going to be a little bit easier to leave it as is, plus 100 over negative 2.19. And so let's go ahead and plot this. So here's the equation of the line. So we got our nice y-intercept at negative 45.662 and a positive slope going up from right to left of that value. And just for fun, if you want to see what that approximates to, it becomes 0.245x minus 45.662, and you see it goes right on top. Boom, done. So again, in this one, I'm going to show you how to do this on Desmos as opposed to a TI calculator. We don't even need to put it in slope-intercept form, but I'll do it anyways. So first I'm going to multiply both sides by x. So we have 200 minus 30y equals 70x. Then I'm going to subtract 200 from both sides, like so. Boom. And then divide everything by negative 30. So I have y equals 70 over negative 30x minus 200 over negative 30. Again, this will reduce to 7/3 negative x plus, you see the minus and the negative cancel out to become 20 over 3. So here's the graph of the line, and you can see that there's my nice y-intercept at 20/3 or 6.667, and it's got that nice negative slope down 7 over 3. Boom, done. Starting with the standard form of the equation ax plus by equals c, solve this expression for y in terms of a, b, c, and x. So basically all we're doing is we're isolating y, and that in and of itself will essentially put it into slope-intercept form. So check this out. First, I'm going to subtract ax from both sides. So I'm going to do that right here. So we got by equals negative ax plus c, and I'm putting that x in front of the c to make sure we end in slope-intercept form. Then I'm going to divide everything by b, like so. And we're left with y equals negative a over b x plus c over b. This is the y-intercept. That's the slope. This is the final answer. Done. So even though we don't necessarily need to graph it, I'm going to graph this just to make it a little bit clearer. So first we got to point at negative 1, 1, and notice this is going by 2's. So negative 1, 1, I'm going to plot that right there. So left 1, up 1. Then 2, 0, we go out 2, and we stay right there. Then we've got 3, 3, so that's 3 out, 3 up. And then we've got 0, 4, 0, and straight up 4. So now I'm going to calculate the slope of each side using the coordinates. So again, for this side, it's 3 minus 0, which is 3, over 3 minus 2, which is 1. So this side has a slope of 3. For this side, it's 1 minus 0, which is 1, over negative 1 minus 2, which is negative 3. For this side up here, it's 4 minus 1, which is 3, right? y1 minus y2, over 0 minus negative 1, which is positive 1. So that's a nice slope of 3. And then here we've got 4 minus 3, y1 minus y2, which is 1, over 0 minus 3, which is negative 3. So we got a slope again of negative 1/3. Now, this tells me that this is definitely a rectangle because all of these lines are perpendicular, forming 90-degree angles. And I know that because the slopes are opposite reciprocals of the adjacent side. So this has a slope of negative 1/3. This is a slope of 3. Therefore, they're perpendicular. This is 3. This is negative 1/3, perpendicular. Negative 1/3 and 3, perpendicular. and of course, 3 and negative 1/3 perpendicular. The slope for a wheelchair ramp for a home has to be 1 over 12. If the vertical distance from the ground to the door bottom is 2.5 feet, find the distance the ramp has to extend from the home in order to comply with the needed slope. So slope is rise over run. So it's 2.5 over x. And this is supposed to equal a slope of 1 over 12. So just as we're talking it out, we've created a nice equation that we can easily solve by cross multiplication. So I'm going to cross multiply. X times 1 is x, and then we got 2.5 times 12. 2 times 12 is 24. Half of 12 is 6, so 24 plus 6 is 30, and the answer is 30 feet. Boom, done. The cost of renting a car is $45 per week plus 25 cents per mile traveled during the week. An equation to represent it is this. What is your cost if you travel 50 miles? So X represents miles. I just plug and chug. So I got Y equals 45 plus 0.25 times 50. So 0.25 times 50, that's almost like the same as saying what is 1/4 of 50. So you could do it on a calculator if you want, but 1/4 of 50 is just $12.50. So you can check that. If you multiply 4 times 12.50, you get back to $50. So now I add those together and I get 57.50. And when we represent money, we want to remember to include up to the hundreds. So 57.50, boom, done. Suppose you have a maximum of $100 to spend for the rental car. What would be the maximum number of miles you could drive? So here we're actually solving for X and we're given a Y value. So I'm going to take my equation here and plug 100 in for the Y value. So I've got 100 equals 45 plus 0.25x. And then we're just going to solve for X. We're going to isolate. So I'm going to minus 45 from both sides. And we get 100 minus 45 is 55 equals 0.25x. Then we're going to divide by 0.25 on both sides. And the cool thing is dividing by 0.25 is just like multiplying by 4. So we can actually do this mentally. 4 times 55 is 220. So it's 220 miles. Boom, done. I hope you guys enjoyed this video. And if you did, please click that like button. And if you want to see more from the Scalar Learning channel, make sure to click subscribe. Thank you guys so much for joining, and I'll see you in the next video. Take it easy.